Section 5.2 is on verifying trig identities, and this is sometimes a really difficult part of the course. You really have to think and use the identities that you learned, and then you're trying to prove that one side of something is actually equal to the other side. So a few tips. Learn the fundamental identities. The better you know them, the easier this will be. Number 2, work on the more complicated side to try and match it to the other side. So you'll only work on one side. You won't touch the other one. It's often helpful to put everything in terms of sine or cosine. We've done some of that in section 5.1. Use factoring or algebraic operations. So in other words, if you had 1 over sine plus 1 over cosine, you have to get a common denominator. The common denominator is sine theta cosine theta. You turn each of these fractions into one with that denominator so that you can write as one fraction. So let's look at some practice problems before we go to your problem set. All right, so in this first one it says perform the operation and simplify. So we're not proving identities right now, we're just simplifying. So we have cotan theta plus 1 over cotan theta. So up here I showed how we could turn cotan over 1 equal to cotan squared over cotan, because this is the denominator we're trying to get. So then we have cotan squared over cotan plus 1 over cotan. Pythagorean theory, when we put these two together, we have cotan squared theta plus 1 over cotan theta. This is equal to cosecant squared theta over cotan theta. If we go a little bit more, and we turn everything into sines and cosines. Cosecant squared is equal to 1 over sine squared. Cotan is cosine over sine. So we have 1 over sine squared times, flip this, sine theta over cosine theta. The sines cross out, at least one of them here. So that's sine squared, so we're left with a sine theta. And we are left with 1 over sine theta cosine theta. Simplify tan theta parentheses cotan theta times cosecant theta. Well, we're going to distribute. We're going to multiply tan by both of those things. So we have tan theta cotan theta plus tan theta cosecant theta. At this point, we're going to change to sine and cosine. So tan is sine over cosine, cotan is cosine over sine, tan, sine over cosine, cosecant, 1 over sine. This all cancels out and you're left with 1. Sines cancel, you're left with 1 over cosine. So we have 1 plus 1 over cosine. This is equal to secant, so we can simplify all the way to 1 plus secant theta. This one has 1 over sine theta minus 1 minus 1 over sine theta plus 1. You need an LCD to subtract these two fractions. The lowest common denominator is the 2 multiplied together. So what you have to do is take each of these fractions and change them into a fraction that has a denominator with both. So I teach equivalent fractions with a backward Z. So I say sine theta minus 1 goes into this. What's left? Oh, the sine theta plus 1. Go up, multiply it by whatever's here, and then that goes here. So you end up with sine theta plus 1. Sine theta plus 1 goes into this, only leaves this. Go multiply it by 1 and end up there. So now we have sine theta plus 1 minus sine theta minus 1. Make sure that's in parentheses all over that denominator. Then this minus distributes here, and we have sine theta plus 1 minus sine theta plus 1. The minus sine theta and the positive 1 cross out. You have 1 plus 1. So you are left with 2 over sine theta minus 1, sine theta plus 1. If we go ahead and multiply these two, we get sine squared theta minus 1, which is equal to cosine squared theta. Negative 2 over that is the same as negative 2 secant squared theta. Lots to do in that one. Sine squared theta minus 1. On this, we just factored that out and got those. I think these must be factoring. This one, sine squared, 2 sine squared x plus 3 sine x plus 1. So it's easier if you let a be sine x. If that's the case, then I've got 2a squared plus 3a plus 1. That's a little easier for us to think about factoring. So I have 2a plus 1 and a plus 1. Then I can put my sine x back in. So it factors to 2 sine x plus 1, sine x plus 1. This one says simplify. Again, we're changing things to sines and cosines. Sine over cosine times cosine over 1 equals sine. Secant squared x minus 1, that's a regular identity. Here's the identity here. If we subtract the 1 over there, we see that we get tan squared. Now we're verifying identities. And the way I like to do them is to work on one side, and when I get down to what I have as the right side, I circle them both and draw an arrow saying, yes, they are identical. All right, so for this one, you would be given cotan theta over cosecant theta equals cosine theta. Well, this is obviously the more complex side. So we're going to work over here and try to change it into this. So cotan is cosine over sine. Cosecant is 1 over sine. So we're going to flip this one and multiply, and the sines cancel out, and I'm left with cosine theta, which is what I was trying to get. So check on that. The next one, 1 minus sine squared theta over cosine theta equals cosine theta. We'll work on this side. Well, we remember that 1 minus sine squared theta is cosine squared theta. So in this step, I changed that to cosine squared theta. If I divide cosine in, I'm left with just a cosine theta, which is what I was trying to get. So check. Tan squared theta plus 1 over secant theta equals secant theta. We're going to work here. So this identity could be written as secant squared theta over secant theta. And we're going to divide, and we're left with 1 secant theta. And there we go. Cosine theta over sine theta cotan theta equals 1. So I'm going to change this bottom into sines and cosines. Sine times cosine over sine. Those mark out. I am left with cosine over cosine, which is 1. So you could have a million different identities to verify. The more you practice, the better you will be. Let's go look at the problem set you'll encounter in your homework. All right, number 1, fill in the blank. This is just to remind you, when you have something squared minus something squared, you can factor it to p minus q times p plus q. That comes in handy when we're doing the trig. All right. Number 2, sine squared theta plus cosine squared theta. That's equal to 1. Tan squared theta plus 1 equals secant squared theta. Sine of negative theta is equal to negative sine theta. This is all straight from your identity sheet. Fill in the blanks. Tan theta is equal to 1 over cotan theta, and that's equal to sine theta over cosine theta. So those are both things you could use instead of tan. Perform the indicated operation and simplify. So here's what we first did. I distributed tan to both of these. So tan x cosecant x minus tan x cotan x. Change to sines and cosines. We did that in the lecture notes. Sines cancel there and there. Cosines cancel there. You're left with 1 over cosine minus 1. This becomes 1. And so that's secant x minus 1. 1 over cosecant squared theta is sine squared theta. 1 over secant squared theta is cosine squared theta. Those two added give you 1. So that's a multiple choice, but you need to be able to see that. All right, perform this. 10 plus sine t squared plus cosine squared t. So over here, if I square this, remember I've got 10 plus sine times 10 plus sine. That's 10 times 10 is 100. That's 10 sine and 10 sine. That makes 20. And then sine times sine is sine squared t. And then we had a plus cosine squared t. So this is equal to 1. So now I have 100 plus 20 sine t plus 1. Then I can combine the 100 and the 1. So I have 20 sine t plus 101. Tan squared y minus secant squared y. And they're just asking you to do that we did in the very first question. Tan y minus secant y, tan y plus secant y. Number 10, 3 cotan squared y plus 7 cotan y plus 2. Let's just let x be cotan y, and then we're going to substitute. So we rewrite it as 3x squared plus 7x plus 2. That factors. We have 3x plus 1 and x plus 2. That does give me what I need. And so it would be 3 cotan y plus 1 cotan y plus 2. Factor this trig expression. So I'm going to let x be sine squared z, because this is to the fourth and that's to the second. So that's going to be 16x squared minus 40x plus 25. That factors to 4x minus 5 and 4x minus 5. So that becomes 4 sine squared z minus 5, 4 sine squared z minus 5, or, and this is how I think they want the answer, 4 sine z squared minus 5, all of that squared. Then we get to verifying an identity. All right, so this is the side we're going to work on. And so they're doing this in steps. That's kind of helpful. So cosecant x is 1 over sine x. Cotan x is cosine x over sine x. What transformation is made in the numerator? Well, that's reciprocal identity. And I think that they have I can't tell how they have the choices, but that's what we're saying. And then in the denominator, that's a quotient identity. Okay? And then when you actually divide, you get 1 over cosine x, which is equal to secant x. That again is reciprocal identity. So they're having you do the pieces and just remember what kind of identities those are. 13. Secant squared x, secant to the fourth x minus tan to the fourth x equals 2 tan squared x plus 1. All right, so over here, if we break this apart, we're breaking this, sorry. So we have secant squared minus tan squared and secant squared plus tan squared. And secant squared minus tan squared is equal to 1. So 1 goes there. All right, then transform secant squared x. Well, secant squared x, so secant squared is equal to tan squared plus 1. So right here, we changed secant squared x. And then that left me with 2 tan squared x plus 1. That was a Pythagorean identity that we changed there. Okay, and so we changed the left side into 2 tan squared x plus 1. Last one, use graphical methods to conjecture if the equation is an identity. So choose the graph of y equals cosine squared x over sine x. So I did that, and I did it in the calculator, and I did that one in blue, and I came up with C. And then I did the graph of cosecant x minus sine x. I did that one in red, and I chose the correct graph. And it says, is this an identity? Well, when you do it on your calculator, they overlap each other, and you can see really well that that's the same graph. When you do your window, it tells you to do negative 2 pi to 2 pi. That's your x min and your x max. And then negative 5 and 5 is your y. And your scale is pi over 2 for your x. So I think you can do that on the calculator pretty well. So hopefully that will help you in practicing verifying and simplifying identities.